All right, so I'll go through both parts because B requires you to use the part from A. All right, so in this one, you're using the growth factor equation, which is basically y is equal to A, some original amount, times 1 plus some rate divided by the number of compoundings per year times the number of compoundings times, or to the power of t, to the power of the product number of times of compounding times the time. So this is kind of your growth equation right here. And so what you're going to do in this is you're looking to find what R is. So here we're only going to calculate the interest once per year. So the n value is just 1. There's only one compounding per year. So we can pretty much eliminate these two, right? So if we plug in the values that we have, it went up to 9,000. That's the current price. It started at 5,200. That was the original price. 1 plus R is our growth factor. And then to the power of t, well, it asks in the last 5 years. So that's a value of 5. And so this is the equation that you would use to solve for the interest rate. And so this will be the first part of this problem. So if I calculate this through, I get 9,000 is equal to 5,200 times the quantity 1 plus, I'll use x to the power of 5, comma x, tells the calculator that's what I'm solving for. Okay? So when I hit enter, I should get my solution. Let's put it in decimal form. Okay, so I get my rate to be about 11.596. Which in terms of percent is 11.6%, if I round it to the nearest tenth. Okay, so there's my answer to part A. Now what I'm going to do is I'm going to use this to calculate part B. Okay, so on part B I'm going to take this same equation right here, but now I want to find what will the price or cost be 5 years from now. So if I start with my original amount, which was 5,200, my 1 plus, now here's where what I do differs from what the book did. The book just used the 11.6, the answer from part A. And so the part rounded to the nearest tenth, so this is 0.116. To the power of, and now if we went 5 years, 5 additional years, the total value t would be 10 for this. So if we evaluate this answer, 5,200 times the quantity 1.116, so this is our growth factor, right? Considered the rate of change here, all to the power of 10, and hit enter, then we get the answer that they're looking for, which is 15,582.79. Okay, so this is what the book, or this is what is going to be accepted as correct on there. Now, if it was up to me, and I'll go back in and change it, because I talked about this in my other class as well, what I would do is I'd use the exact R value in my calculation. So when I created this equation right here, instead of taking 1 plus 0.116, I'd take 1 plus, and I'd use this exact answer, the exact rate that I calculated. So I'm just going to get rid of the x equals part here. And so the answer that I would get is $15,576.92. And so either of these is fine. This is the book, which is an approximation, and this is more exact because we used the exact interest rate or the rate of growth versus the approximated one.